This is a continuation of the example 2 for Coulomb's law using the vector analysis. And just as a review, here is the orientation of the charges. You have the two positive charges along this axis, the Q2, which is negative, and at a point here, and Q4 above it at the center of this triangle. So it's the points or vertices of a pyramid. And in the last video we calculated the vectors for charge 4. We're going to solve the force for charge 4. So we found the vectors that we needed. Notice that it has a 4 in each one, and then it's the combination of all of the other charges except for charge 4. We got our distances, we calculated our unit vectors. Now we're ready to use our force formula. So we have the force. Remember, this is going to be a vector for on 4, charge 4 from charge 1. So I'm going to equal k of the charge times Q4 times Q1, and we don't need the absolute value sign like we did with the component view. We have to keep this without the absolute, divided by R14 squared times our unit vector R14. And that's going to be 9 times 10 to the 9th Newton meter squared per Coulomb squared times, well, Q4 is set at -5 times 10 to the -3rd coulombs. Q1 is 10 millicoulombs, well, or I should say 10 to the negative, 10 times 10 to the -3rd coulombs over, and now I need the distance based on vector 1, 4. So I'm going to have the square root, and I'm going to convert this to meters. I didn't need to do that to get the unit vector, it wouldn't matter, but now since I'm doing everything in meters, I'm going to convert it. So that's going to be minus 0.03 meters squared plus 0.015 meters squared plus 0.03 meters squared So I'm going to have the square root, and I'm going to take the square of that. And then I'm going to have my vector, my unit vector, of minus 0.667, comma 0.333, comma 0.667. And now when I calculate that all out, I get 1.479 times 10 to the 8th negative 7.397 times 10 to the 7th and minus 1.479 times 10 to the 8th newtons. So that's the force on charge 4 due to charge 1. Now we have the force on charge 4 due to charge 2. Q the charge times Q4 times Q2 over distance of R24 squared times my unit vector 24 Now I just have to fill in all my values here. And I'm going to have for the distance, here's my R24, so it's going to be 0 meters squared plus negative 0.015 meters squared plus 0.03 meters squared. I'm going to square that whole square root, so it's squared, square root, square. And then my unit vector, 0, comma, negative 0.447, comma, 0.894. And the result gives me 0, comma, negative 5, let's see, negative 5.359 times 10 to the 8th and 1.072 times 10 to the 9th newtons. And now force charge 4 due to charge 3. Q the charge, Q Q4, Q3 over the distance squared times unit vector. Remember that the indices flip. So it's 9 times 10 to the ninth Newton meter squared per Coulomb squared negative 5 times 10 to the minus 3 coulombs. And for charge 3, that's 15 millicoulombs. Well, sorry, I should put that back into coulombs here, just so that we have it right. So 15 times 10 to the minus third coulombs over, and here's my vector, R34. So I can get the distance. .03 meters squared plus 1.5, actually, need to change that. I want to put it in meters. Plus 0.03 meters squared, have a square root, squared. Alright, and our unit vector, 0.667, 0.333, and 0.667. And that leaves me with a vector negative 2.219 times 10 to the 8th negative 1.11 times 10 to the 8th and negative 2.219 times 10 to the 8th newtons. And now, to get my total force, the force on charge 4 is just equal to vector 4(1) plus force on due to charge 2 plus the force on charge 4 due to charge 3, and that's just going to equal the addition of all three of these vectors. Just writing down all of my vectors here. Ooh, almost out of room. Okay, just fit it all in there. And now I just have to add all the first coordinates, add all the second coordinates, and add all the third coordinates. and I get a final force equal to negative 7.397 times 10 to the 7th and minus 7.208 times 10 to the 8th and 7.02 times 10 to the 8th newtons. So that is the force in vector form for the force on charge 4 due to all the other charges. Now I can calculate the magnitude, and that's just using the Pythagorean theorem, and that comes out to be 1.009 times 10 to the 9th newtons. So that's the resultant magnitude of the force. But this is the forces in each of the three directions. This would be the I hat direction, J hat direction, K hat direction. So that's the solution for charge 4. You can find the solutions for the force on charge 1, 2, and 3 in the notes, but it's all very similar. You just got to keep track of the subscripts. If you can keep track of the subscripts, you'll be fine with these problems.